So, part 3 of section 2.2, find k such that the line is tangent to the graph of the function. So we have a function here, k minus x squared, and we don't know k, we're trying to find that. We know that y equals negative 6x plus 1 is tangent to our graph. So what does that mean if it's tangent to the graph? Then at a certain point, those two should have the same slope. We know the slope of this is negative 6. How do we find the slope of this? You take the derivative. You should know now that slope is derivative. Slope is one application of derivative. To take the derivative of k is a constant, like 5. The derivative of 5 is 0. So we have 0 minus, and then the derivative of x squared, you put 2 out in front, so it's 2 times x to the power of 2 minus 1. You subtract 1 from the exponent, so 2 minus 1 is 1. So the derivative of any tangent line of this graph will have the slope of negative 2x, depending on what that x value is. So k minus x squared looks something like this. Because it's a negative x squared, we know it's going to be upside down parabola. And any point I choose, any x value I choose, if I plug in that x value into this negative 2x, that will give me the slope of a tangent line. I want a tangent line of negative 6x plus 1. So that's probably going to be somewhere over here because it has a negative slope. This over here would have a positive slope. So I know that this tangent line isn't over there on that part, it must be over here somewhere. I just need to know what that x value is. So this x value here, I don't know. I need to know what that is. But if I know this is a little equation that will tell me the slope at any point, and I know I want my slope to equal negative 6, what things? You set them equal to each other because I want my slopes. So negative 2x equals negative 6 at x equals 3. So here is 3. This is 3. Now I would like the y value. I need a y line and on this curve. Well, I don't know enough information about this curve right now to be able to tell what the y value is. So going to be the y value for this line. So if I plug in 3 here, that will give me this y value of that point of tangency. So y equals negative 6 times 3 plus 1, negative 17. So I know that the point of tangency is 3, negative 17. That point is on both the curve, so if I know that the point 3, negative 17 is on this curve, I can use negative 17 for f of x, k, and I know x is 3. So just plug in 3 for x and negative 17 for the y. That's negative 17 equals k minus 9. Add 9 to both sides, 8. So what I'm saying is that I have a function f of x equals negative 8 minus that has a tangent line at negative 6x plus 1. All it's asking for is to find k. So I believed, but I'm going to verify that using my graphing calculator. So when I graph these two functions here, this one, I should see a graph something like this if I zoom out. X is 3 and then that negative, so 3, negative 17 there. There's the curve of, so there's the y-intercept of negative 8 minus x squared. And this is the graph of negative 6x, like we did it right. The next example, find an equation of the tangent line to the graph of f through the point that's not on the graph. So I want an equation of a tangent line to the graph of f, which is 4x squared, through a certain point, and they tell you 4x squared, and I've got some other point over here, I don't know where it is, of 5, 0, and I want a tangent line that goes through that point and also hits the curve. I'm not sure. They tell you in order to find the point of tangency, which is x, y right here, you're going to use this little formula. F prime of x equals 0 minus y, which we're trying to solve for, and x sub 0, which is 5, minus the x we're trying to solve for. And we're going to do that all to find an equation of the tangent line to the graph of f. So once we have these 2 points, then we can find the equation of the line. All right, so we need to find the derivative. Derivative of f of x, 4 times, and then you multiply the 2 out in front, and then subtract 1 from the exponent. So the derivative of this graph, 4x squared, is on the curve. we want that to be equal to, so using this little formula up here they gave us, f of x equals y sub 0, which is 0, x. I've got too many variables in here. So I need something to put in place of this letter y, because I don't want a combination of x's and y's. So what could I use in place of this y? Plug it into the straight line equation, I'll get a certain value, or if I plug it into the curve, I'll get that same value. Well, I don't know the equation of this straight line, but I do know the equation of the curve. So, because whatever x I plug in for this point x, if I plug it into 4x squared, it will give me the y. So now I have 8x equals negative 4x squared. Okay, and I want to solve that, so I'm going to do cross multiplying. So I'll have negative 4x squared equals 8x times the quantity 5 minus x. Remember, 4x squared equals 40x minus 8x squared. Add 8x squared to both sides and you have 4x squared equals 40x. So I have 4x squared minus 40x equals 0. You can factor out a 4x. So you have, and if you have two things that multiply together to equal 0, one or the other has to be 0. So either 4x equals 0 or x minus 10 equals 0. Here, if we solve this, x is 0. I've got two places where I might have a point of tangency, 0, 0 and 10, or not 0, 0. Yeah, it is 0, 0. You find that by plugging it into here, or 10 to find both of those equations. So the equation that goes through the point 0, 0 and 5, 0, y2 is 0 minus 0 over 5 minus 0, 0 over 5 is 0, so the slope of that line would be 0. So y equals mx plus, okay, y equals mx plus b. Put in 0 here and here. So b is 0. So your equation is y point 10, 400. And it also goes through the point 5, 0. So 0 minus 400 over 5 minus 10, 5. I believe that's 80, so that's our slope. I'll do it this way this time. Y minus y1 equals m times x minus x1. Y minus times x minus 5. Y equals 80x minus 400. Yeah, those are the two equations that satisfy what they're asking us to do. The next one is, the next example that you'll have on your homework are problems like this. Find plain old boring slope. These are x values, so I want the slope from 3 to 3.1. So you're going to have to find the y values that go with 3 and 3.1 by plugging them into the equation and then finding the slope. So we're going to find that. And then we're going to compare this average rate of change with the instantaneous rate of change, which is the derivative at the endpoints. All right, at 3 and 3.1. So 3 squared minus 7 is 9 minus 7, which is 2. 3.1 squared minus 7 is 2.61. So the average rate of change, called the average ROC, is 2 minus 2 all over 3.1 minus 3. So 0.61 divided by 0.1. That's the average rate of change in this interval of f. Now let's take the derivative. Oops, that's an x. I mean, that's a t, not an x. Derivative of t squared is 2t. Derivative of 7 is 0. So the derivative, the instantaneous rate of change at any time t here, is 6. The instantaneous rate of change at the endpoint is 6.2. The average rate of change is pretty close points. So comparing them, I would say that f prime of 3 is less than the average rate of change, which depends how they write the answer in the back of the book, but comparing means just explaining if they're equal or one's bigger or one's smaller. All right, so that should, and the homework, 115, 65 to 75 odd,